Greetings of the day. Welcome to the e-content series. I am Sowmyadevi from Department of Computer Science and Engineering. I am going to give the brief description of about operating system fundamentals concepts. To in this series, I am going to discuss about what is the introduction about operating system, process, and how the process of scheduling, schedulers, types of process. First of all, process and then types of process. And then we are going to see about the main topic CPU scheduling. In CPU scheduling, what are the criterias we need to understand first? And then what are the types of CPU scheduling? In the types of CPU scheduling, we are going to see only two main important scheduling, that is round robin and priority scheduling. Operating system. Operating system is the interface between our user and the system. That means hardware of the system. Hardware is in our that whatever the user wants to interact with the system, OS is the main part. In OS, kernel is the main important, that is the heart of the OS, which gives the interaction between the user and the system or the hardware. Okay, in this, what do you mean by process? A process is called as a unit of execution. That is, whatever the process, whatever the program is in execution state, it is called as a process. In each and every process, we have three important things. What is a program counter, stack, and data section? That is, what is the counter of each and every process which is in execution. Stack includes what are the data and other items needed for that particular process to execute. For a process to execute, each and every process must be reside, or it must be come to the main memory for the execution. Whatever the program or data we will be stored in the we will be stored in the secondary memory, and for execution it has to come to the main memory for execution. That means why it has to comes to main memory, why we are not storing the program or data, whatever the thing, we are not at all storing permanently in the main memory, because the main memory is not permanent memory, and the main memory is very small in size. Because it is too costly, we can't able to build in very large size, and also it is not permanent storage. Because what happens means, whenever any power failure or any system failure occurs, the data which is resides in the main memory will be lost. That means when after the system has been recovered, the data will not be available in the main memory. So to maintain the data permanently, we are storing the data in the secondary memory, and secondary memory is large. Okay, so due to this reason, we are storing the data in secondary memory, and whenever the program or anything we have to execute, means we have to bring that program from the secondary memory to the main memory for execution. So whenever the process, each and every program has number of process, each unit of execution is called as a process. So that process has number of states. That means whenever the process is ready for execution, it has to come into the main memory. So we are calling it as a new process. And then if it is ready, that means number of process will be available in your main memory for execution. All the process will be waiting in a queue called ready queue. So in that ready queue, when the process is created, it will be directly entered into the ready state, and it's wait for the CPU for execution. Okay, it has been first reside in the main memory, and then when it is ready for execute, it will be entered into the ready state, and it has been ready for execution. So when the CPU has been alerted for it, it will be executed. That means it will comes to the next stage running. That is, once the process is ready state, it has been chosen, and according to the scheduling algorithms, it has been given the CPU for that process, and it is executing, that is running. And if there is no any interrupts, if it is not at all waiting for any input output device inputs, and it is completes its execution, means it will goes to the last stage, that is terminated, the process has finished its execution. Or if it is waiting for some event to occur, that means if it is waiting for input from any input output devices or input from any other process, means it has to wait for that input. So it is waiting, so it will be entered into a new next state called waiting. or if the process is in ready state but it has been moved to the secondary memory from the main memory due to some lack of resources, that process is called, that state is called as a suspended state. So here, as the process is ready for execution, it has number of states to number of states from starting to the ending, that is new state, ready state, running state, waiting state, terminated, and suspended state. That we have, I have described this states now, and it has been pictorially represented here. That is new, it has been admitted to the ready state. If it is ready for execution means ready, and then it has been available in the, that means it is available in the main memory for execution, and it is waiting in the ready queue for executing if the CPU is free, and it is ready for, and it can be entered into the CPU means it will be entered into the running state, and it is does not wait for any input output devices inputs or any process inputs means it will be completed and goes to the exit state, that is terminated. Or if in the running state, if it is ready for, sorry, if it is waiting for some any input output devices event to occur means it will be entered into the waiting state, and after getting those inputs it will be again go to the ready state and enter into the running state. Okay, this is the process state of how the process are executing, how it is changing from one state to other state. If there is not at all waiting for any input output devices means it will goes directly to the last stage, that is terminated stage. Next, context switching. Just before I have explained you that number of process is moving from one state to other state. So how it means if it is waiting for some other events means it has been waiting state. So that is called as a what? Context switching. Context switching is one of the fundamental concept in operating system, that before switching from one state to another state we have to do something. That means we have to save first one, save the context, what the process, that means up to what stage the process has been executed, we have to save it in using the registers and program counter. And next, loading the context. Loading the context means we have to load it, that up to what stage the process has been executed, we have to save it, and then the next process has to comes to ready for execution, so we have to load the new process. And next, the last one is switch the execution. So now the new process has been arrived, so we have to load it, and then the new process is to ready for execution. After its completion, if the old process is now ready to execute, we have to switch the old one to the, sorry, new one to the old one. So this is called as a what? Context switching. This is a very, very fundamental concept. That means we have to switch from one process to next process. Next, now we are going to see process scheduling, how the process is scheduled. That means why we want to schedule it, because we have seen that our system is a multi-processing system. At a time, a multiple process can execute, and then it gives the, if it executes efficiently, and it improves the performance of the CPU. So at a time when multiple processes are executing, we can achieve the performance. So for that we have to schedule the process. How we can schedule? For scheduling we are using three types of queue, that is job queue, ready queue, and device queue. Job queue means all the process, set of all the process in the system. Ready queue means that set of all the process residing in the main memory and ready, and it is waiting to execute. And next one, device queue, that means that a set of process waiting for an input output devices process and migrate among the other various queues. This is, that means this queue is generally stored as a linked list. Okay, mainly we are using these two queues, job queue and ready queue. Ready queue we have seen in the last example, that, sorry, last pictorial diagram. If your process is ready to execute, it will be waiting in the ready queue. Now schedulers, that scheduling we are going to do, who will schedule that? That means your schedulers are going to schedule the process. First, which process wants to execute, and next which process wants to wait for some time. Or for all those things we have three types of scheduler, that is long term scheduler, short term scheduler, and medium term scheduler. That is long term scheduler means, yes, we have to, this is a short decision only, that is for long time. That means if a process is ready to execute from the memory for execution means that job is going to be done by long-term scheduler. Next, short-term scheduler. That means short time this process is going to execute. So that scheduler will select which process is going to execute. For that, we have to allocate the CPU for execution. And last one is medium-term scheduler. This is the thing that is, if any process is wants to wait for something, that time we have to remove that process from the memory and we have to reintroduce some other process into the memory for execution to be continued. That is main thing, means we should not make the CPU should be idle, because if you keep CPU idle means the performance will be decreases. So we should not keep the CPU idle. So for all the things we have to consider, all the things we use three types of schedulers: long-term scheduler, short-term scheduler, and medium-term scheduler. Just now we have seen the short term and long term scheduler, and then types of process. What are the types of process available? Input output process, bound process, and CPU bound process. That means what it is. The process spends more time during input output computation that has many short CPU bursts. That means if your process is going to compute for so much of amount of time for input output process, that is called as a input bound process. A CPU bound process means the process spends more time in CPU computation rather than input output. Then it is called as a what? CPU bound process. And then other type of very important thing, now we are going to see that what is the, we have just seen what is the basic, that is input output bound process and CPU bound process. And next one we are going to see is non-preemptive and preemptive. Non-preemptive process and preemptive process. What is this? This is a very familiar term we have read while coming across our operating system concepts. That is, non-preemptive means once a process has been allocated to the CPU, that means it has been entered for execution, means the process cannot be removed from the CPU until it terminates. Okay, that means once a process has been entered into the CPU for execution, we should not interrupt it until it has completed. So that CPU should be given for only the process, and none of the other process should interrupt that process. That process is called as non-preemptive. Next one is preemptive. If a process is running in CPU, consider, and at the meantime, if the process is interrupted by other process due to some considerations, that is the upcoming process has higher priority, that means that time this running process is interrupted by the new process. It will be removed from the CPU and the CPU will be allocated to some other process. That is called as a what? Preemptive process. This is a two important things we have to be keep in mind. Non-preemptive means the process should not be interrupted at any cost. Preemptive means the process can be interrupted and the CPU can be given to some other process. This is called as preemptive. Next one, CPU scheduler. In this, we are going to see how the CPU scheduling is going to perform, and we have that means four types of CPU scheduling. For the CPU scheduling, we are using CPU scheduler or dispatcher. So for dispatcher, consider that what is the job of dispatcher. That means it will give the control of the CPU to the process which is selected for the CPU for execution. Okay, and latency. What do you mean by dispatch latency? The time taken for the dispatcher to stop one process and start another running process. It is called as I was saying latency. The time taken. How much time it takes for selecting one process to stop it and giving the CPU to another process. It is dispatch latency. And next one. These are all the important criteria we need to understand before you are going to enter into the CPU scheduling concept. First one, CPU utilization. That means how the CPU has been kept as a busy as much as possible. That is called as CPU utilization. Next one, throughput. Throughput means how many number of process has been completes its execution per unit time. It is called as throughput. Next one, arrival time. Arrival time is nothing but the time at which the process enters into the ready state. The time at which the process enters into the ready state is called as arrival time. Next one, burst time. Burst time means the amount of time. Amount of time. Here we are mentioning it as an amount of time taken by the process to complete its execution. For which represents CPU time for completing the whole process. That is called as burst time. Arrival time means the time at which the process enters. Burst time means the amount of time taken by the CPU for completion. Completion time means what? That this is the time at which the process completes. Next, turnaround time. Turnaround time means the amount of time is needed to execute a particular process. That can be calculated as turnaround time. TAT is nothing but turnaround time is equals to completion time minus arrival time, or waiting time plus burst time. And waiting time, how you can calculate waiting time? For how much time it has been waiting for the CPU. That is amount of time the process has been waiting in the ready queue for execution. That is turnaround time minus burst time. Last one, response time. At what time this process has been responded by the CPU. That is called as response time. These are all the important criteria we have seen. We should understand before we are going to see the CPU scheduling types. First, there are 4 types of CPU scheduling algorithms. That is first come first serve, shortest job first, round robin, and priority CPU scheduling. Here, first come first serve means from the title itself we can understand that which process comes first, it has to be served first. Second one, shortest job first means if we have considered 5 processes at a time, among the 5 processes which has the less burst time, that process will be given the CPU, and according to the burst time the process will be executed. That is shortest job first. Next, round robin CPU scheduling means it will take a round of all the process. It will give the time for all the process based upon the time quantum. That means first it will take P1, P2, P3, P4, P5, and based upon the time quantum means consider the time quantum is equals to 2. That means for 2 seconds P1 will execute in the CPU. After next 2 seconds, P2. Next 2 seconds, P3. Next 2 seconds, P4. Next, after 2 seconds, P5. Again, it will come to P1. That is called as round robin. Next, priority CPU scheduling. Priority CPU scheduling means from the title, it has given the keyword priority. Priority means among the process which has the highest priority, that process has to be given the CPU for execution. That is called as priority CPU scheduling. Now we are going to see the first, that means the first algorithms are basics, very easiest one. And now we are going to see the round robin algorithm. Already we have seen that based upon the time quantum, the process is going to execute. That is similar to nothing but first come first serve. Okay, consider this is the problem I have taken for explanation. In this problem, I have given 5 process and their arrival time and burst time. Okay, we have to compute completion time, turnaround time, waiting time, and response time. See here, so for this round robin, we have to maintain ready queue and we have to draw the Gantt chart. Gantt chart is used to representation of the completion of the process. The round robin, I have given the time quantum equals to 3. Okay, well, at the arrival time 0, which process arrives first? P1. So P1 has to be taken first, and for 3 time quantum, 3 seconds, P1 will execute. So if for 3 seconds P1 is executed means the remaining burst time is 5. So again it has to execute, but it will not allow the P1 to execute. It will give the chance to next at 3 seconds, after 3, that means after 3 which process has been executed, which process has been arrived after 3 seconds. See, at 1 second P3 has been arrived. Why not P2? Because it is going to arrive at 5 only. So we have completed only 3 seconds. So at 3 seconds P3 only has been arrived. So P3 has been given chance. So P1 is in ready state and P3 is in ready state, ready queue. So P3 is given for execution. So 3 seconds it will execute. So what is the burst time of P3? 7. 3 has been completed. So remaining 4 seconds is there. Okay, at 6 seconds, after 6 seconds, which has been executed? P1 is already there because P1 is not at all executed fully. So because we have remaining 5 seconds to execute, so we enter the P1 in the ready queue, and after 6 seconds P2 arrives and then P4 also arrives. And then what is this P2? Yes, P2. Yes, P2 is arrived and P4 is also arrived. Okay, now after completing P3, now which is in the ready queue? P1 is in the ready queue. So take P1 again. Okay, now after 3 seconds, here we have left us 5 seconds. So after the 3 seconds, P1 is going to execute. So remaining 2 seconds is there. Okay, it has not at all executed. So you have to enter again in the ready queue. Okay, and then P1 after that means at 9, what all the process has been ready, will be waiting in the ready queue. Already P2, P4 is there, and P3 also has been executed once, but its remaining time is 4 seconds. So we have to enter the P3. And next, now P5 arrives. So at this time, at 9, after 9 seconds, all the 5 process has been arrived. And now we have to see whether which process has been entered next to P2. And we have to give the chance for after P1 who is there in the ready queue, P2, after next P4, next P3, next P5. If it has been done completion means, see near P4, here in P4 the P4 completion burst time is 3. So in P4 here for 3 seconds it has been executed, so remaining there is no time for P4 to execute because its burst time is 3. So there is no need to execute P4 again, so it is not at all entered here in the ready queue. So based upon the ready queue, all the process will be given a chance for 3 seconds and has done the completion of its each and every process. This is round robin. Each and every process, first P1, P3, P2, according to the ready queue which is available in the ready queue, the process is given for the chance. Okay, and now after this Gantt chart, with this Gantt chart only we can able to solve this problem. How we can able to find out the completion time, turnaround time, waiting time, and response time. Completion time means, see P1. P1 has been completed at 22 seconds. So that is 22. And P2 has been, now P2. Now when P2 has been completed here, 11 seconds. P3. P3 has been completed at 23. P4. P4 has completed at 14. That is, I have written 14 here. And P5 had completed 25, 25. And using the formula, turnaround time is equals to what? Completion time minus arrival time. We have calculated the turnaround time, and waiting time is equals to burst time, turnaround time minus burst time. That is waiting time. And what is this response time? Response time means, see at P10, at what time if the P1 got has been responded by the CPU. At 0 has been arrived. At the same time 0, P1 got responded by the CPU. That means it has given chance for the CPU to execute. So the arrival time, the response time is 0. Now come to P2. P2 has arrived at 5, but what time it has been responded? 9. So 9 minus 5, 4. Like this we have to calculate the response time for all the process. This is round robin algorithm. Based on the time quantum, this algorithm is working. In this, what is the disadvantage means, this algorithm is similar to FCFS, and if the time quantum is large, it will resemble same as a first come first serve only. So we have to mention the time quantum should be very small. If it is very small means number of switching will be more, and also it will take some time. So you have to keep the time quantum time should be not very less and not to be too large. So it should be 10 to 100 milliseconds. So this is the one disadvantage of your round robin algorithm. Next we are going to see priority scheduling. So we have seen that based upon the priority, the process will be scheduled. Okay, here I have considered the which process as the highest priority, that process should be given the first priority. So this is the problem I have taken for the priority scheduling. In this, I am going to take the process should be non-preemptive. Non-preemptive means if P1 has been entered into the execution means it has to complete its execution completely, and then only next process can enter for execution. That is non-preemption. P1 should not be interrupted by P2. That is non-preemptive. If the priority scheduling is preemptive means, if P1 is executing, at the same time P2 arrived with the highest priority when compared to P1 means I can interrupt it. when it is preemptive. But here I have taken about non-preemptive priority scheduling. Okay, so as 7 processes are there, and I have given all the priority, arrival time, and burst time. Okay, and then we have to compute which process are going to execute first. So as upon the time arrival time 0, which process arrived first? P1. Okay, but it has the priority is 3. Why not P7? Because it has the highest priority 1, but it is going to arrive at the seconds 10 second 10. So it has not at all arrived, but it has highest priority. Which has arrived now? Only one process P1, which has the priority 3. So I am going to take the first priority 0, sorry, P1, which has the priority 3, it has arrived at 0. Okay, and then it will complete it fully, and then only it will give the chance to the next process. So for 8 seconds it will be executed. P1 is completed. At 8, see, at 8 any other process has been arrived? Yes, at 8 P6, P5, P4, P3 and P2 has been arrived. Among these process, which has the highest priority? P5, which has 2. Okay, less number has the highest priority. Based upon this concept, we are taking the priority process. Okay, so it has the highest priority 2, so P5. So P5 has given chance for execution, and what is the P5's burst time? 6. So 6 seconds the P5 is going to execute. So after its completion 14, at 14 seconds the remaining one process also arrived, that is P7, which has highest priority 1. Okay, so now among the remaining the process which has highest priority P7, less number has the highest priority. So P7 is going to enter into the execution. So 1 second it is going to execute because its burst time is only 1. So it is completed. And after that remaining is next highest priority is P2 because next priority is 4. Already 1, 2, 3 has been completed. Next 4. Here at time, the process 2 process having the highest priority, that is priority 4, P2 and P3. So which process we wants to take, either P2 or P3? So we don't know. But based on what concept we are going to select the processes? First come first serve. Which has arrived first? P2. So P2 going to be select first. So it enters into the queue and it is burst time is 2, and for 2 seconds it will execute its completion. And next P3 is executing for 4 seconds, and after completion P4, and next P6. P6 is the last one which is going to execute because it has the priority number 6. So based upon the priority the process are executing. And then after finding out the completion time, turnaround time, waiting time and response time, same method is used for computing the completion time, turnaround time, waiting time and response time. What I have explained how to find out these times in last method, the same method only we are using here to find out the answer for all these times. And then after finding out, if they ask you to find out the average waiting, turnaround time, response time and waiting time, means we have to find out the average. And this is your two scheduling concepts we have seen today, that is round robin and non-preemptive scheduling. What is the disadvantage in non-preemptive priority scheduling? That is number of process. That means if the process which is ready to execute but it has the lowest priority, but highest priority process is also arrived, so it has to enter into the CPU, and lowest priority has to wait for so long, so it leads to starvation. And if the processes never get chance for execution, still it is waiting for so long due to its priority, means it is also one kind of starvation, and it is getting aging for, that means it will wait for so long time for execution. So this is one of the demerit here, because the process has never entered into the CPU for execution, so when it will execute. So these are all your disadvantage of your priority scheduling. So in this series we have seen on introduction for the process and process scheduling, and how the process has been scheduled using CPU scheduling algorithms, that is round robin and priority scheduling algorithms. Thank you.